Example 4. Verify trigonometric identity by factoring. So we want to verify all this. Now remember, we always start on the complex side, so this problem is very easy to see that the left side is definitely the most complex. So when I look at this, the first thing, there's a few things that stand out to me. Here's one, is that I have a cosine here, some secants, and I have a cosine over here, a tangent, and a tangent. I have multiple of those. Well, here's what I want to try to do first to simplify, is I'm going to say when I have all this, bunch of long lists like this, I'm going to change it to sines and cosines and see what I can cancel. So I first have a cosine. That's a pretty simple form. I'll leave that. But the secant squared, I'm going to use its reciprocal to get it to a sine or cosine. Secant's reciprocal is cosine. If you're not sure, go to your reciprocal. Secant's reciprocal is cosine. So secant squared is the same thing as 1 over cosine squared x. So I'm doing reciprocal identities right now. Now, and quotients identity. And so here we have, and let me slide this part down. If it'll let me, yeah. Okay. So tangent is the same thing as sine, psi y cos x. Tangent is y over x, which is sine over cosine. And then I have minus here. Continue on, minus. Cosine's already in good form. Tangent is psi y cos x. Tangent is y over x. Sine cubed x over cosine cubed x. So the first thing I'm going to do here is notice I can simplify this problem here. So we wrote that, and now I will simplify. This cos cancels with one of those. I'll just choose that one. Over here, this cos would take away one of those. And so I would have, when you simplify, sine x over cosine squared x minus sine cubed x over cosine squared x. Now we have a common denominator. So I can factor and simplify here. Because a common denominator will become one denominator here. That'll be cosine squared x. And I can also factor, and the factor part I'll do in red. So we'll factor in red. Factoring, what's common up in the numerator? They both have a sine x. So I could actually pull out the sine x. And so it'd be sine x. If you divide that out, you'd be left with 1 minus sine squared x. Okay, so now I have a 1 and a squared. That's bringing me back to that Pythagorean identity. So if I go to Pythagorean identity, to have 1 minus sine squared x, I'd have to subtract this across, but that would be equal to cosine squared. So what I'm going to do over here next is I'm going to write the Pythagorean identity. That's our next step. So I'll do the Pythag next. And so the Pythag would say that this right here, this part, is actually equal to cosine squared. So the rest stays the same. We'd have sine x over the cosine squared x. But this would become cosine squared. Now, I simplify one more time. This goes away here, there, and so we're left with sine x. That was what we intended to get from the very get-go, so we did it correctly. Now we got one for you to try.